Okay, in this lesson we will convert the general form equation of a circle to the center radius form. So, step one, reduce all the terms in the equation by the greatest common factor if possible. So let's look at the example and we'll just go back and forth and apply the step to the equation. So, example one, change the equation to standard or center radius form, then name the center and radius of the circle. So here we have this general form equation of a circle. We're going to reduce everything by the greatest common factor of 3 because we have x squared, y squared, we have 3 coefficients, and everything else is divisible by 3, so it makes sense to divide by 3. The resulting equation is x squared plus y squared plus 4x minus 8y plus 19 equals 0. Step 2, group the variables x's together, y's together, writing in an empty box for each variable group. So, before we do that, let's, just like when we complete the square, let's subtract out the number 19, the constant, from both sides. And then let's group together the x's. So we have x squared plus 4x plus box plus y squared minus 8y plus box equals negative 19 from here. Sorry, that's a messy 19, but that's negative 19 plus box plus box. Now, why do we have 2 boxes? Because we added 2 boxes to the left of the equation, so we have to add 2 boxes to the right of the equation. Okay. Step 3, complete the square. Not once, but twice. So don't forget, you have to use the formula b over 2 squared to find the number for each box. So what goes in here? Well, b is 4, and 4 over 2 is 2, and 2 squared is 4. So if we put a 4 in this box, we put a 4 in this box. Negative 8, half of that is negative 4. Negative 4 squared is 16. So if we put a 16 in this box, we will put a 16 in this box. Moving on to step 4. Rewrite the trinomials as a perfect square binomial and simplify the right side of the equation. So we're literally going through the steps of completing the square when we're changing this formula to a center radius. So I'm going to highlight for you the x's, and I'll use a different color highlighter to highlight the y's. So this is the x's trinomial, this is the y's trinomial. So we want to rewrite this perfect square trinomial as a binomial squared. So we know this is going to be x plus 2 squared, and the y's will be y minus 4 squared. Let's clean this over here. We have negative 19 plus 4 plus 16. 4 plus 16 is 20, and 20 minus 19 is 1. So we end up with 1 over here. So, I hope you recognize this equation because this is center radius form. The center of this circle is located at negative 2, 4, and the radius, now remember that this number here represents r squared. So the square root of 1 is 1. The radius is 1. And there you have it, ladies and gentlemen. We have converted the general form equation to the center radius form equation of a circle, so we can easily see what the center is and what the radius is. We'll look at a final example here. We have 4x squared plus 4y squared minus 40x plus 48y plus 224 equals 0. We're going to divide everything by 4, giving us this resulting equation. We're going to subtract 56 from both sides, and we're going to group all the x's together and all the y's together, including the empty boxes on the left and the 2 empty boxes on the right. Finally, I'm going to highlight the x's in blue, highlight the y's trinomial in yellow. Let's determine what goes in the boxes, and we do this by the formula b over 2 squared. So 25 goes here, which means 25 goes here, and 36 goes here, which means 36 goes here. So now we can rewrite these trinomials as a perfect square binomial, x minus 5 squared plus y plus 6 squared. Sorry, I made that. There we go, forgot the plus sign. And 25 plus 36 is 61, and 61 minus 56 is 5. So, putting it all together, the center is 5, negative 6, and the radius of that circle is square root of 5. Best of luck to you. Thanks for watching.